So we'll look at a couple of worked examples to do with conservation of energy. And in the first one, we've been asked about velocity, so we're obviously ending up with kinetic energy. We're told it's a frictionless plank, so there's no friction involved. Plank's 5 metres long, and one end is 3 metres above ground level. So in actual fact, the fact that the plank is 5 metres long is irrelevant because there's no friction. There's no friction involved here. What we have then is potential, gravitational potential energy converting to kinetic energy. So it's only the height that would matter there. So in terms of what we know a height is 3 metres, and that's it. We're being asked the velocity. We don't know the mass, but what we do know is that the potential energy it had at the top will equal the kinetic energy it has at the bottom. So EK equals EP. So a half mv squared equals mgh. But now we can see that the m's cancel out from both sides. So even though we don't know it doesn't matter. We would just divide both sides by whatever it is. So we have a half v squared equals gh. We can plug in now a half v squared equals 9.8 times 3. So v squared is 58.8. Just watch when you're cancelling out a half from both sides. Remember what you're doing then is multiplying both sides by 2. It's very easy to half the right hand side there. And a v squared is 58.8 and v is square root of 58.8 for our final answer. And then another one, a trolley of mass 1 kilogram is released from rest from top of a ramp with one end 1 metre above the horizontal. So we've gone through our information. We've got a mass, we've got a height. Trolley reached the bottom slope, it's travelling at 3 metres per second, so we've got velocity. How much work is done against friction? And your immediate thought might be, oh well, it's asked me work done, I'll do work done as force times distance. But you don't have a force, you don't actually have a distance either. So it's going to be done by conservation of energy, looking at the information you've got. So basically you can work out the potential, you can work out the kinetic energy, and the difference between them will be the work done against friction. Okay, by conservation of energy. That potential energy to start with must convert into something. So some of it's converting to kinetic and the rest will have been converted to heat, mostly, and a wee bit of sound because of friction. So in terms of what we know, we've got a mass of 1 kilogram, we have a height of 1 metre, and we have a final velocity of 3 metres per second. So the first thing we're going to work out is EP equals mgh, and substituting that we get 1 times 9.8 times 1, which is 9.8 joules. Similarly for EK equals a half mv squared, is a half times 1 times 3 squared. Remember, show your substitution, don't just go straight to the 9, which is 4.5 joules. So the work done due to friction is the difference between these. You started with 9.8 joules. You know where 4.5 of that has gone, so the remaining 5.3 joules is the work done against friction. Okay, and that's a good example of one where you don't just immediately jump in and say, oh, it's asked me work done, I must be using the work done as force times distance formula. In conservation of energy, you need to think about what types of energies are involved, can I work any of them out and use this conservation to get the final answer.